Doc here with a short tutorial for Physics 101, Light and Visual Phenomena, Refraction. Know your two basic cases. When light goes from a fast medium to a slow one, the light bends toward the normal. The normal is your dotted reference line, which is perpendicular to your interface, so that you have a cross formation with a right angle or a 90-degree angle here. When you go from a slow medium to a fast medium, the light bends away from the normal. So a slow medium means light travels slow, a fast medium, light travels fast. Then you want to know your index of refraction formula. N is C divided by V. The C is the speed of light in vacuum, which you memorize to be 300,000 kilometers per second. V is the speed of light in the medium we are considering. N is the index of refraction for the medium we are considering. C divided by V. Suppose the speed of light in the material is 200,000 kilometers per second. Well, you write down your 300,000 kilometers per second up here, which you memorize, and then divide by 200,000 kilometers per second, and you're basically taking 300,000 over 200,000. That's 3 halves, 1.5. The index of refraction, which corresponds to glass. Memorize the index of refraction for a few cases. Vacuum is 1, air is 1, close enough to vacuum, water is 1.33, glass is 1.5, diamond 2.4. Then to see it in action, we go here to this applet. If we go from air or vacuum, this is N is 1, which is vacuum, or air is close enough to vacuum, and this would be water. The light ray bends toward the normal. Notice that the light ray that comes in is actually shared. Some light gets reflected and some is transmitted. Notice that your normal incidence is coming straight down, where the angle of incidence is 0 degrees, and the reflected angle will be 0 degrees, and your transmitted angle will be 0 degrees. Notice all angles are measured referenced to the vertical normal here. The normal 20 degrees angle of incidence, angle of reflection 20 degrees, angle of refraction less than 20 because you're bending toward the normal. Here if we go to 60 degrees, angle of reflection the same, 60 degrees, angle of refraction 40 degrees, once again less than the incident angle because we're bending toward the normal. If we are to reverse these and go from water to air, the light bends away from the normal. Now here for 20 degrees, the reflected angle is at 20. Reflected angle always the same as the incident angle. And here, since we bend away from the normal, we're greater than 20 degrees. Notice that when you go from a material where light travels slower to one which travels faster, you can bend away from the normal so much at one point where it just skims the surface. We basically say that's a 90 degree refracted angle. If we just back up just slightly right about there, and that's called the critical angle when that occurs. So it's about there at 49 degrees, the critical angle, where the refracted angle is 90, and then anything greater than that, all the light is reflected. That's called total internal reflection. And we might look at one application of various cases where here we have the fisheye view of the world. If we look at light directly from the bottom of the post, we have a direct ray. If we look at a reflected ray, this light here is reflected because you're coming where you have reflection all the time. But in this case, since there's no ray up here, this is total internal reflection. We're greater than the critical angle. And the fish sees an upside down post, which means a post now that was down here is pointing up. And here, a refracted ray from air to water, the fish thinks it's raised up there quite a bit. So if we look at our example with a photograph from underwater, we see the legs pointing down, direct ray, legs pointing up due to the reflected ray, and the refracted ray gives an upper torso raised into the air. That's it for the short tutorial. I hope you enjoyed it.